All right, so this is the next assignment, the last assignment, which is web securing single page applications, which asks you to do a lot of what we just did in class, right? To configure cookie parser and the session, and set up a session secret. Make sure you configure that on Heroku, and perhaps also configure it locally on your machine. And don't forget to do a dash save and verify that the libraries indeed were added to your as dependencies to the package JSON. And then asks you to load the core passport library and initialize it and tell it to use the current session. And then it asks you to refactor the various services as we just demonstrated in class, right? Implementing the serializer and the deserializer. Although the model is a little bit different. I was using a user model. I think it's using a developer model. And then implementing the local strategies to implement the local strategy that looks up the username and password from the credentials, and then notifying passport on whether the user is valid or not valid. Okay? And then go back to each one of the components that implements the login, that implements the registering, right? And refactor them to use new services, login services, and registration services, and store it in local shared services, right, to be used by other components all throughout the application. Right, so refactor the login services, the registration services, right, and use the new request options, right, to configure the security for each one of these services. Okay, just like we did in class. And implement the login. So basically what we've been doing all throughout class, right? Then implement logout, which we haven't done yet. That is going to allow us to invalidate the currently logged in user, so that now they'll be configured invalid users, and that they would have to log in again if they want to go back to secure parts of the application. Okay. So implement logout, a refactor registration, right, and make sure that now the navigation, when you navigate to the profile, you no longer provide the ID of the user. Instead, that information is being maintained on the server side. Here's the new implementation for the registration client service. Refactor the registration web service as well. The new entry point for the register web service that is going to not only create the user, but once the user is created, it's going to log in the user. It's going to make it the currently logged in user and respond with the brand new user. Login, also implement the, okay, so this logged in, which we haven't implemented just yet, this is going to be used so that as the user navigates throughout the secured portions of the application, we always want to go check to the server. Hey, server, is it okay if the user navigates to this portion of the application, right? Because the server is going to be the owner of this knowledge on whether the user is logged in or not. Okay, no longer will be the responsibility of the client, right, to maintain state where that there's a currently logged in user. It's always the client will always go back to the server and validate. Hey, am I still logged in? Am I still logged in? Have I timed out? Right? Has my token gone bad? Am I not in a valid state anymore? So we're going to implement this new endpoint on the server called logged in, right? That's going to be used all throughout the rest of the application. After having the user been challenged with a login page, right? Once they've been challenged, once they've provided the credentials, once we have stored and made a note that they have already authenticated themselves, and we're going to store it in the session, next time around, as they navigate through the secure portion of the application, we're going to go back to the server asking, are they still logged in? Are they still logged in? If they're not, then we're going to kick them back to the login page. Okay? But here, we're always going to go back to the server, and the server is just going to respond, request.isAuthenticated. Right? That's a new function that's going to be implemented by Passport. Right? Passport is going to look in its session, in its cache, to see if the request.user is still valid, and if so, it's going to return the current request.user. Otherwise, it'll return some value that we can you all agree that this is not a valid user. So here I'm returning just 0, right? If it's not authenticated. Back on the client. Okay, we implemented the shared service to maintain the to keep track of the in the client side the current user. We're going to implement on the service, on the user service, the query out to the server. Hey, is this person logged in? Is it logged in? Is it logged in? Okay. Now that we have the service and the client side, go back to the server every time and check to see if the current is logged in. What we're going to do is that we're going to protect the profile. You will not be able to go to the profile unless you're logged in, unless the server says you're logged in, right? Not the client. The client can always be fooled, can always be hacked by knowledgeable JavaScript developers, right? And the JavaScript is publicly available. You can see the code right on the client side. You can step through it, right? Some JavaScript hackers can look at the JavaScript code and try to make sense of the logic and try to fool it or change the variables, right? And thwart by trying to force the JavaScript application to let it go into a place where they're not authorized. Yes. So we always need to rely on the server. The server has the truth always on who is logged in or not. So what we're going to do is that we're going to protect the profile page by implementing a new service called the Authentication Guard service. That is going to its only purpose, it will be to implement a guard, right, on whether we can activate. Can we activate this URL? Can we activate this component, right? And this is a new. We've been using path, we've been using component, and this is a brand new property in routes, right? Is this route valid? Can we go to that route? Is it okay to go to that route? And who's going to say yes or no? Our servers, our authentication guard service, right? Which we're going to implement. And we're going to implement it by creating our own brand new service, which implements an interface called canActivate, right? So you can put here a whole bunch of an array of services that can vote on yes or no whether you should be allowed to go to this route. Okay? And each one of these services will be notified and say, hey, is it okay with you if this person goes to that route? Right? And then it'll iterate over each one of these services. Right? See if anybody has anything negative to say about going to this route. If anybody fails, if anybody says no, right, then the navigation to that route is aborted. Right? They all, if you have an array here of services, right, and any one of them votes no, then the whole navigation is aborted. Okay? Here we only have one authentication, right, guard, and it's this one right here. Implements this interface. And that interface has a single method. It's called canActivate. And the way it works is that this canActivate is going to iterate over each one of these, calling each one of them canActivate, 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 right? And depending what they return, right, we'll vote yes or no. Okay. And here, what we're doing is that we're returning logged in. We're returning whatever the user service.loggedin says. Meaning, I don't know, I need to go to the server to determine this. Right? It's going to go out to the service, to the server, which we implemented earlier, and there it is. Okay, so here it is. This is the return true. This return true is the response to the can activate. Okay, so this goes out to the server, comes back with a user. If the user is not 0, actually this is without quotes. If it's not 0, actually like that. If it's not 0, that means that the server did not respond with a 0, meaning it responded with a real user. Okay, then that is the currently logged in user, and the can activate returns a true. So this here returns true. Yes? Returns true. Yes, you can activate. Otherwise, if it is 0 from the server, then it's going to return a false. And by the way, I'm going to navigate you back to the login page. Right. If I don't navigate to the login page, the page is just going to display blank. I'm not going to show you the profile page, right? Because I can't render it. Right? I've been voted out. I can't activate. But here I am explicitly kicking you back to the login page. Make sense? So logged in, the server says yes, you're authenticated. You can go to the profile page. The good thing about this is that having implemented logged in once, I can now use this can activate to protect any private, any route, right, that I want to protect, that I don't want folks to go in unless they are authenticated, right? So I implement this once, and then any route that I want to protect, I can just copy this and paste it. Well, this might be silly. You can't go to the login page unless you're logged in. That makes no sense, right? Or maybe I so other parts of the profile, or I can't see the websites, or I can't see any of those. Anything beyond the profile should be inaccessible unless you're logged in. Make sense? All right. Login component. Okay. All right. So, right. So that ends the implementation for the protecting the profile. The next part is what we haven't talked about. Is what we're going to be talking about next week on implementing the Facebook strategy. Okay, which we haven't covered yet. You'll need to create, expand the user schema. The user schema currently just have first name, last name, username, password, things like that, right? We're going to expand it by adding Facebook, a new attribute, Facebook or Google, whatever. I think we're saying Facebook here. Yeah, we're saying Facebook, and we're going to be storing the user ID that is going to come back from Facebook. Facebook is going to provide us with a user ID of that user. And a token that's going to tell us how long this is the last valid token that we know the user used. Okay, we're going to add to the user model. We're going to add a new finder. Right. Currently, we have a find user by ID. We're going to add a find user by Facebook ID. All right. So that we can retrieve a user by its Facebook ID, by their Facebook ID. So this is passing the Facebook ID, and we're comparing it against Facebook.ID because this is an ID inside of an attribute Facebook. So Facebook.ID, that's what we're going to be comparing. And in the login page, we're going to add a button that is going to use a Facebook logo. Right? This is a Facebook logo that is available in Font Awesome. So you're going to need to load the font awesome CSS library, and it's going to generate an auth Facebook to the server. The server is going to be configured to load the password. You already have done this, but now it's going to use a new strategy, the Passport Facebook strategy. It's going to receive a request from your login page. Your login page is going to point to this URL, and Passport is going to then take your request, your button that you click that I want to log in with Facebook, and it's going to redirect it to Facebook's login page. Right? Passing the request saying, asking for permission that I want to know your Facebook email. I'm requesting that Facebook provide me the email from Facebook. Right? Facebook will challenge the user with on their servers with their username and password to log into Facebook. If it's successful, Facebook, well, it's successful or not successful, is going to come back to us here. Right? It's going to come back. We're gonna be listening for a callback from Facebook. Facebook is going to generate a request back to our servers, at which we have to be ready to answer and whether it's successful or not, right? We're going to redirect the user either to in this case would be not user, would be profile, or the login page. We're going to kick back the user either to the login, if Facebook comes back as a failure, or if it's successful, we're going to kick them to the profile page. Okay. You're going to have to configure Facebook. Facebook is going to you're going to have to register your applications with Facebook. Right. You're going to need to go to Facebook developers website. Right. Register as a developer. And say I want to register a new application, and you're going to have to provide your Heroku URL. You're going to have to give it a name, and Facebook is going to give you a client ID, a client secret, and a callback URL. The callback URL is going to be this URL right here. This one is going to be your, something Heroku app.com/OAuth Facebook callback. Right, you're going to provide that also there, and tell Passport that you want to use your new Facebook strategy, right? And implement how to retrieve the user from the database. And finally, we want to make sure that the passwords that we're storing in the database, right, that those are not stored in clear text. Right now, right, all the usernames, password, all that information is being stored all in clear text as JSON objects. Right? Any system administrator that has access to a database can look up all those users and read what the username and passwords are, yes, and log in as yourself. So what we want to do is to make sure that those passwords are encrypted, okay? So that even if someone has a system administrator access to that database, they won't know what the passwords are, right? To encrypt those passwords, we're going to be using this library, the bcrypt Node.js library, which we can use to hash the password before storing it in the database, and then we can go the other way around. These are one-way encryption, right? So it's stored encrypted in the database, and we don't have access to it. Nobody can ever know what the original password is, right? Instead, next time when somebody logs in, we take the new password that's coming from the client, we encrypt it again, and we compare it with the current password that is already encrypted in the database. Right? If they match, then it must be the same person, right? The same password, and then we either successfully log in the person or we reject the user. And there's some user validation as well. If we want to, as the user fills in the forms, right, of login, or when they're registering, or when they're providing new websites, we want to highlight we want to highlight and give some feedback to the user if certain required fields are not provided, right? And say, sorry, we want to say this field is required, right? So we're going to do some validation on the client side as well using just standard form validation Angular support. Okay? And that's the assignment. Questions? All right, so let's keep going.